Question number 4. Figure 1 shows a line L1 with equation 2y is equal to x and a curve C with equation y is equal to 2x minus 1 upon 8x squared. The region R shown unshaded in figure 1 is bounded by the line L1, the curve C and a line L2. Given that L2 is parallel to the y-axis and passes through the intercept of C with the positive x-axis, identify the inequalities that define R. So, in this question, the main idea is to identify the inequalities that define R. Alright, let us look at the region R. The region R is bounded by this straight line, which is 2y is equal to x, by this dotted line. We don't know the equation of this line, and by this curve. Okay, so since the region is defined by these three lines and one of them is missing, the first thing we need to do is to find the equation of the missing line or missing dotted line. Now, let us look at what the question is giving us. The question tells us that the line L2, which is the required line which we are trying to find out, is parallel to the y-axis. So we know that whenever a line is parallel to y-axis, it has its equation in the form of x is equal to a certain number. Now we don't know what that number is, but as we can see, the straight line is passing from the intersection of this line, which is the positive x-axis, and the portion of the curve. So if we are able to find out what is the coordinate of this point, we will be able to find in turn the equation of the dotted line. So let's solve these two lines simultaneously, which is the curve and the positive x-axis, to find the x coordinate of this point. Okay, so we have the equation of the curve y is equal to 2x minus 1 upon 8x squared, and equation of the x-axis is y is equal to 0. So as both these lines have their left hand side as y, we can equate their right hand sides and solve 2x minus 1 upon 8x squared is equal to 0. We can see here the denominator is 1. We can multiply top and bottom by 8. So now we have 2 8s are 16x minus x squared divided by 8 is equal to 0. So the 8 multiplies with 0 and becomes 0. We are left with 16x minus x squared is equal to 0. Now we factorize to solve it. X into 16 minus x is equal to 0. Therefore, x is equal to 0, or 16 minus x is equal to 0. 16 is equal to x, or x is equal to 16. So our two solutions are x is equal to 0 and x is equal to 16. Clearly we can see that this line and the curve intersect at 2 points, one being this and one being this, and we found the coordinates of both of them. Clearly this was 0, we already know, and we found this one as 16, and hence now we know the equation of the dotted line is x is equal to 16. Alright, now since we know equation of all the lines that are the boundary to the region, all we need to know is the direction for the inequality. So let us begin from the first line, the one which we just found, the dotted line. Equation of the dotted line is x is equal to 16. We can clearly see that the region is to the left of the dotted line, which means if the boundary is 16 here, obviously to the right will be greater than 16. So since we have to be to the left of the line, it has to be less than. So we have x is less than 16 as one of our inequalities. Alright, so this is one of our answers. Moving on to the other equations, we have the other equation, which is 2y is equal to x. That is the equation of this line. Alright, so we need to find out the direction of the inequality for this region. So whenever we need to find the direction of the inequality and it's not clear or easily seen by eye, as we could see for the first equation, what we can do is we can take any point which is in the true region. Now as you can see, the line divides the plane into two regions. One is on the lower side and one is on the upper side. But which is our true region? Our true region is the one which is below the line, which is this one. And why do we say this is our true region? Because this region contains the required area that we are looking for. Alright, so that's why if this is the line, this is the true region for us. Now we will take any test point in the true region. So the test point that I have chosen is 16, 0. Okay, so that is in the true region, and by plugging in this point into my equation, I will find out the direction of the inequality. So let's take my test point as 16, 0, which means my x coordinate will be replaced by 16 and my y coordinate will be replaced by 0. So 2 times 0 and x will be replaced by 16. So I have 0 and 16. So obviously 0 is smaller than 16, but I will make it equal to, because it's a solid line. Alright, if it had been a dotted line like the first one, we would just leave it with the less than sign. Here, since it's a solid line, we include the equality sign as well. Alright, moving on to our third equation, which is y is equal to 2x minus 1 upon 8 x squared. Now this is our curve. Alright, this is our curve. Our curve is dividing the plane into two parts. One is the part below it and the other is the part above it. Alright, we can clearly see that the part that contains our region is the part which is above the curve, and that is this part. Alright, so we will take any test point in this part, which is the true region. Alright, and we'll plug it in to find the direction of the inequality. So the point that I have chosen, the test point, is 16, 2. So the x coordinate will be replaced by 16 and the y coordinate will be replaced by 2. Now I will rewrite this. I need to establish the direction of the inequality. 2x minus 1 upon 8 x squared. Alright, now I plug in the values. So for y I plug in 2, for x I plug in 16, and here again for x I plug in 16. So now I have 32 minus 1 upon 8 into 256. I can cancel 8 ones are 8 32s are, and now I have 2 and 32 minus 32 and 2 and 0. Clearly 2 is greater than 0, so I have the greater than sign here. So that tells me the direction of my inequality. So the direction of this inequality is greater than or equal to, and the direction of this inequality is less than or equal to, and we have this one as our second answer and this one as our third answer, and all these three define the region R.